Hey everyone, welcome back to another Lightning Pod. This is Alessio, partner and CTO at Decibel, and I'm joined by Swix, founder of Small AI.
Hello. DeepSeek is all the rage. It was the biggest news story in the world. DeepSeek was the number one downloaded app in the US App Store in January, which is crazy. And we're looking for a guest, and Tim has been blogging about R1, S1, and all the other stuff. So welcome, Tim.
Thanks.
Tim, what do you do?
I'm a software engineer. I've been the CEO of Entropix, which is just a two-person startup. We're winding that down, and I'm kind of transitioning into a different role.
More consulting and all that. So what got you interested in, you blogged about like an R1 explainer, pretty early on, and how have you been sort of exploring DeepSeek?
So I think I've just been kind of listening quietly on Twitter, and I hear little rumbles of different papers, and so every now and then something strikes me as like, oh, this is really important, but people aren't talking loudly enough about it. So the R1 thing, that one came the same way. I just heard something, people were talking about it, didn't seem like enough people were talking about it, so I wrote it really plainly. And I think it resonated with a lot of people. And the same thing with S1. People were like basically vague posting about it on Twitter. And I was like, no, this is a pretty big deal, I think.
Yeah, it seemed like so there's a meta question about, I'm looking at your recent posts, right? You didn't really, weren't really like, you explain stuff. And you sort of learn in public, but like what's your blogging strategy? Like, should I do this? Like we debated having a DeepSeek blog. Alessio actually even wrote one, but I was like, I don't think we're saying anything new here. I don't know, like.
So I don't know if I have like a overarching strategy aside from the ones that do well are the ones that I know people want ahead of time.
Yeah.
So some of the ones like the AI engineering primer, that one, I was mentoring somebody, and he was asking me a ton of questions. I'm like, man, I should just write this down. So that one did okay. R1, I was posting on it about it on Blue Sky, and then it was just doing really well. I was like, I'll just consolidate this into a blog.
Yeah.
And then S1 the same way. I think if I test out the topic. And see if people are actually interested in it, and then consolidate pretty much.
Okay, cool. Should we double click more on R1, or should we go into S1? I'll give a fork in the road here for the two of you.
S1. Let's go to S1.
Let's go to S1. All right. So S1 came out more recently, and we cloned DeepSeek for $6. Is what the headline is?
Yeah, you need something to grab people's attention, Wait, it is important. Like the cost reduction is important. I'm not sure it's really like the major thing here, but it is definitely something that is eye-catching for sure.
So I've like vaguely, I've read through the paper. I think the main claim, there's sort of two claims, which I think you explained it a little bit. Main claim is that DeepSeek had some inference time scaling, but they didn't exactly replicate the test time scaling chart that O1 had, and also that you could basically replicate it by inserting a weight token or think token. And that was a big part of it. The other part was that it was very sort of there was a little bit of fine tuning with like 1,000 examples. Basically, that's why it's $6. Like otherwise, you don't really need $6. That's my TLDR. I don't know if you would disagree or modify that in any way.
Yeah, no, absolutely. Yeah, I was just thinking about the R1 paper, or actually the S1, the O1 paper. So many letters and numbers. Like they had that graph, the graph on a log scale, the accuracy versus the compute that they put into it. And I'm thinking about it, and like you could just put harder questions are going to deserve more thought naturally, but that's kind of a wonky way to graph things out, because if that's all you did, then what the graph would be saying is that the harder questions you get, the more accurate they are, and that seems a little weird. So they're clearly doing something else, right? That's where when I read S1, I was like, oh, that's how they're doing it, right?
Yeah. I'm also kind of curious about the distillation. So basically, a lot of people are saying that DeepSeek, distilled or stole, even if you want to use very politically charged words, from OpenAI. It seems like you can distill from like just the outputs, which is interesting because you don't need like the process rewards. Here they also had like really interesting, I guess there's some kind of filtration process, right? Or it's like, data frugality, you said.
Yeah. I mean, it's kind of crazy that if you know what you're looking for ahead of time, you only need 1,000 examples to get like that kind of boost. Which is enough. Like one person could do that if they're focused. And I was thinking about this. That's one of the advantages that OpenAI has, because the 3 criteria they're looking for. So data quality, which is just basic. The text is complete. They're also looking for diversity, like different topics, and then they're also looking for like different how hard a question is. When they're sitting there listening to your ChatGPT conversations, you're automatically giving them diversity because you're interested in lots of different things, and they can just look at how long the LLM takes to respond to figure out the difficulty. You're giving them basically 04, 05, 06 just by using their web app, which is kind of crazy.
Yeah, like I'm also trying to wonder, like, what is it? What goes from here, right? Like, is the goal to just copy this for every open model in the world? How should people think about like the implications of S1?
I think copying is interesting because then you get smaller and smaller models, but it's not very interesting. It's more of a curiosity. I think one reason why I think this particular blog did well is because it seemed easy all of a sudden. Like all this AI stuff seems really difficult most of the time. Then it's like, oh, you just put like a weight token in. Got it. Okay. I think that's really just suddenly it seemed like, oh, this is accessible. Where this goes, I think this is where like I mentioned Entropix in there. Entropix is basically automating this. So what they did in the S1 paper is they just looked at the length of the output so far, and if they wanted to generate more, like to replicate the graph, they would just stick another weight token, go a little longer, and keep on going, sticking it again. Entropix uses the internal signals from the model. There's been a few papers saying that the entropy of the model will indicate the model's confidence. So if it's feeling unsure about the answer, you should see it in the entropy and also the var entropy as well. The var entropy is just like the slope of the entropy in a sense. You can just think about it as like on the blog, on the GitHub repository, they have some kind of flowery language to describe entropy versus var entropy. It's like entropy is like the clarity of the like if you're looking at the horizon, how far can you see? And then var entropy is like the patchiness, like if there's clouds. But really, you can think of var entropy as kind of like the how much the entropy is changing. So if it's changing a lot, that's potentially that there's multiple valid paths to take that seem clear. I guess one good example is like if you have, let's see, James as the first token. The next token could be like, who are some people named James? Like
Bond.
James Bond. There's one, right? And then some other person named James, right? Those two seem like very clear. So the var entropy is going to be high, but the entropy is going to feel pretty low in general.
Yeah.
So like the Entropix, they're trying to listen to the internal entropy of the model to figure out which path to take. And so,
is it just from the vector of logits? Like that's all you need? That's it, right? Like
so that's the core of what Entropix does. They added in also the attention as well, but the core concept is just the logits. That's it. Yeah.
That's pretty simple. What happened to Entropix? Why did it stop? It looks like it's dead.
I'm not part of it, so I can't speak.
Yeah.
But what they've been saying online is basically the
Frog died.
The scope grew a lot, which, I mean, it happens to a lot of projects. Like, so you get this idea and it gets bigger and bigger and bigger. And they just announced, like, today, I think, that they're starting a new company. Maybe yesterday.
Yeah.
So they're starting a new company. So it's grown. It's a big idea now.
Yeah, but I mean, they could have come out with like E1 and then, at least made somewhat of a splash. This like random academic, they kind of took like the most basic implementation and made much more of a splash. Interesting. So like we think that Entropix is still like the right, like using var entropy is actually the right way to do it. This is just the dumbest possible way of doing it, right?
So I think they're going further. Like, so Entropix is just a sampler. It's a dynamic sampler, so it's extra cool. But if you think
what's
about
dynamic about it?
What was that?
What's dynamic about it?
So it's listening to. So it instead of so like a normal sampler would be
top K,
looking at the temperature. You set one temperature for the entire generation. And then taking just the probability of right versus Entropix is changing that threshold, changing the top K, changing the top P throughout the generation, and also potentially resampling entirely or forking, doing two different branches.
Yeah, like fundamentally not too complicated. It's just part of the sort of inference process.
So it's just doing it dynamically though.
Okay.
But if you think about it, all this signal that they're going off of is coming from within the model. And if you can do that at runtime, you should be able to train the model to do it on its own. So I think the direction they're going right now is to embed this into like a RL reward function and get the model to essentially start introspecting on itself, being able to tell itself, oh, I'm unsure, I should probably clarify this, right? Which is it's interesting. It'd be curious to see what kind of behavior emerges when you start training on introspection.
And on the RL point, one of the conclusions on S1 is like that supervised fine tuning also gets good results. But then now you mentioned that maybe RL is still like a good way to go. Do you have any ideas on like, is the S1 path of taking RL models and bringing them into SFT just a way to get smaller models to perform better and then have the advantages of like small inference? But then on kind of like the cutting edge side, you should still do RL, or maybe SFT is also still a good path for cutting edge, but just we need a different approach for data generation.
I don't know. I think you need both. I mean, R1 did both. There seems to be something kind of magical about RL that I mean. To be totally frank, a lot of these machine learning concepts, I just watch my children growing up, and I'm like, oh, I kind of see the same thing, and so you kind of see like just by just giving them small feedback how quickly they learn. Like I think the same sort of thing is going to happen with AI as well, and reinforcement learning is pretty good at that. The supervised fine tuning, it obviously works, right? But you have to. It's a much more hands-on approach if you want to. Like that one, like they're targeting specific, like there was just math, that was it, right? Versus when R1 did the R10, it developed not just math, but in like the whole reasoning ability and be able to think as long as it needed to. It developed that entire ability, right? So RL seems to have like this. It's almost like it. Okay, I guess if you view it as like a plant, I feel like RL causes a lot of growth. Then SFT, you trim it down to like the shape you want it to be, so it's more useful. I think that might be the right way to think about it, but I'm not sure. I'm not a researcher, so what can I say?
Yeah. Like, what do you like? I see you're also in the game of making predictions. What else are you looking for this year in terms of progress? Like, we've already had a lot, and we're, a month and a half into 2025.
I don't even know what to say.
Yeah, what like your hot topics, your pet topics, like stuff you're like, okay, like this is this is something I'm really paying attention to.
So honestly, the thing on top of my mind is really just like the doom loops. I don't know if you've heard that term, but like this, the idea of like you just that the agents kind of get stuck in a loop.
Yep. That's what I was hoping that var entropy, gets you out of.
I kind of think it will. I don't know. We'll see. I don't think the runtime Entropix was really the right answer, but maybe if you do it during training time, it might evolve that capability.
Okay.
That seems like it unlocks a whole lot, because then you get a higher level of just agency in general in these models. But you also get the ability to introspect and say like, oh, actually, I am not confident in what I'm currently doing. Therefore, I should do something that increases my confidence. I should go use a tool to get information, or whatever. Like that's where I think that's where a lot of capabilities start turning on.
Yeah.
It feels like a linchpin that we haven't really talked about a whole lot.
Yeah. Interesting. I think that's partially what deep research had to solve when OpenAI released it. Obviously, Gemini also had deep research. It seemed like, it's a key point, like an operator as well. All the agents that OpenAI is releasing, they're gonna have to resolve doom loops, and they probably have already worked on it. Like maybe not that difficult, but there's no paper that we can point to that says this is how people do it. Like it's just guessing and theory. Yeah. Cool. That's all the questions I had. Any other pet topics or calls to action? Anything else that you want people to check out?
No, I don't think I have anything right now.
All right. Well, thanks for jumping on for a quick pod. We wanted to talk about S1, and your blog post is the top of Hacker News. So thank you for sharing your knowledge and doing the write-ups. Honestly, you do it better. You make me inspired to write more, because like people should, like, even though like this can be out there. Like I think it should be explained well. I think you explained it very well.
Awesome. Thank you.
Yep.
Cool. Thank you, Tim.